Welcome to my math class. I am Mohammed Ali, online maths teacher. Today we will solve one question from Cambridge A-Level P3 book, complex number chapter, June 2004, question number 8. Question number 8 is Roman 1. Find the roots of the equation z square minus z plus 1 equals to 0. Giving your answer in the form x plus iy, where x and y are real. Roman 2. Obtain the modulus and argument of each root. Roman 3. Show that each root also satisfies this equation z cubed equals to minus 1. Okay, now see how can we solve this maths. At first, our question number 8. So equation is Roman 1. Z square minus z plus 1 equals to 0. So we have to use the formula. The formula is z equals to minus b plus minus root over b square minus 4ac divided by 2. So minus, the coefficient of z is minus 1 plus minus root over b square minus 1 whole square minus 4 into a. A is here 1, z square coefficient is a, and c is also 1, divided by 2 into 1. So we will get here 1 plus minus root over 1 minus 4 by 2. So if we simplify, we know that root over minus 3 become 1 plus minus root over minus 3 divided by 2. So root over minus 3 we can write root over 3 into root over minus 1. So if we write it separately, root over 3 into root over minus 1, and we know that root over minus 1 is I. So here we can write 1 plus minus I root over 3 by 2. So z equals to get to value z equals to, we can write 1 by 2 plus I root over 3 by 2, or z equals to 1 by 2 minus I root over 3 by 2. This is our first root, first answer. The two roots of this equation is z equals to half plus I root over 3 by 2, or z equals to half minus I root over 3 by 2. Okay. Now, number 2, we want to find out, obtain the modulus and argument of each root. Okay. Modulus and argument of each root. So for first root, z equals to 1 by 2 plus I root over 3 by 2. So modulus root over z equals to root over the half is square plus root 3 by 2 square. So we'll get here 1 by 4 plus 3 by 4. So finally we get here 4 by 4, so it will be 1. So this is the modulus for the first root. Now argument of z. So we can write it arg z. Arg z equals to 10 inverse. 10 inverse this part root 3 by 2 by half. So we'll get here 10 inverse root over 3. Remember the result, argument result come in complex number always in radian mode. So it will be pi by 3. So for the first root we get the modulus and also we get the argument of z. For the second root, second root is what? Z equals to half minus I root over 3 by 2. So modulus of z equals to root over 1 by 2 whole square plus minus root over 3 by 2 whole square. So it will be 1 by 4 plus 3 by 4. So finally we get here 4 by 4. Again we'll get the modulus of z equals to 1. Now argument of z, so we'll write this z equals to tan inverse this part, imaginary part, root 3 by 2 minus root 3 by 2 by half. So we may write this minus in the front side. So it will be tan inverse root 3 by 2 by half. So we will get here minus tan inverse root 3. So we'll get here minus pi by 3. So this is our second part answer. Now show that each root also satisfy the equation z cube equals to minus 1. Okay. Z cube equals to minus 1, we can write it z cube plus 1 cube equals to 0. So this formula is a cube plus b cube formula is a plus b into a square minus ab plus b square. We just use this formula. Okay. Since z square minus z plus 1 is the factor of this, so two roots obtained from in part 1. The previously we found two roots in part 1 are also the roots of z cube equals to minus 1. So I think everybody understand this math. This is very simple. If you try to understand better, you try to read all these formulas. How can you find out the argument? How can you find out the modulus and root? Thank you everybody for watching. Thank you all.